All right, so welcome back. Introduction to solving quadratic equations. This topic, as you kind of have carried through the various videos that I've posted on this grade 10 kind of quadratic problem. So it relates back to basically, what if you have these relationships, so these quadratic relationships. So you have a relationship between y and x. They're of quadratic form because the x is squared, as you see there. Now I have provided you here two kind of different formats. So the standard format, which is ax squared plus bx plus c, and then the vertex format. Now, of course, we can have one more, which is the factored format. And for those factored ones, they're not always factorable in some nice way that we could get it. But here, what I want to do is, what if now we want to be able to try to solve? If you recall, let's say if we take the equation of a line, y is equal to, let's say 3x plus 15. And now I wanted to be able to say, I know what y is, and let's set y to, for instance, 0, if we wanted to find the x-intercept. And now, once we know what y is, we are easily able to kind of rearrange this equation to solve for x, right? So we can basically take the 15 over to the other side, and then we can divide by 3, and then we're going to get our answer. So what it would be is, so for instance, if I take the 15 over, and then I divide by 3, I am able to very quickly solve the equation. So here's my equation just for x. And now, because I only have one variable. Now our goal here with equations when you're introducing this topic is, what if we wanted to do the same? So what if we wanted to take this value of y, so either here or here, it doesn't matter, and then we wanted to be able to try to solve and figure out what the solution for x would be. So for instance, if I would set this equal to 0, so y is equal to 0, now I'm going to flip it on the other side. So for instance, typically when we write it in school and when we're working with these, so we would write it kind of like this, equal to 0, and this is just simply the value of y. And this is the equation that they talk about in terms of quadratic equations. And now what you want to do is you want to be able to find the value of x, so that, the answer to the left-hand side will be equal to the right-hand side, which is 0. Now, does it have to always be 0 on the right-hand side? No, it doesn't have to be. You can actually plug in any value of y that you like. However, if you plug in the value of y, you can always just bring that value on the other side and it will just change that c for you. So what I mean is, so for instance, what if I wanted to have y is equal to 5, right? And then we have something like this, 3x squared, let's say plus 10x, minus 10. And this to you might say that, well, it doesn't really look like in this form. You're correct. However, if you're going to be doing this, so for whatever value you have, you can always bring this over to the other side. And if I bring it over, then all I'm going to have left here is 0. So this is going to be 3x squared plus 10x, now minus, and instead of minus 10, because you're bringing the 5 over, this is going to turn to minus 15. And notice, basically what you have is you have a quadratic equation here, and that quadratic equation, now instead of it being 10 there as you saw, so you brought that 5 over and it turned out to be 15. So in general, what happens is, for whenever we're trying to solve for some value of y, you can plug it in and then bring it over on the other side, and it will just simply change your c. And then you have a quadratic equation, which is going to be always in this format. And when you're learning this in school, they typically just give you basically just this equation. So they say, these are the quadratic equations we are trying to solve for x. And here is, for instance, one example. So now what we want to do is we want to be able to find this x so that when you plug it in, the answer is going to be equal to 0. That's what we want to do. Now, because this is an introduction and you can't really solve very easily all of these equations, some of them are actually kind of hard, and then you'll watch future videos on how to do it. But in this case, we do have some ability, especially if we can factor out the quadratics. So if you have forgotten about how to factor out, I'll point out a link up above, okay, to factoring out quadratics. And how can you factor things out? Well, you can, for instance, have perfect squares. You can have difference of squares. You can have just general quadratics, which you can factor throughout. Or you might have maybe a vertex form that you are able to solve, right? And rearrange the equation to get what you like. And unfortunately, sometimes, the factoring might not work, and then you need another tool to be able to solve these equations. I'll present that in a future video. But for now, let's take these equations. So for instance, I have 5 equations here, and let's try to see if we can solve for x in these equations so that when we substitute x back, we're going to solve the equation and it's going to equal to 0. Now, if you recall what this means in terms of relations, this really means you're just solving for the intercepts, right? So what is the x-intercept within these parabolas? So for instance, this parabola, so it's going to be kind of looking upwards in a sense, right? So we know that because a here is positive. And then if you want to find the zeros, really what you're doing is that's what you're trying to find out, right? Where the zeros are. So you have done that in the previous videos that I've kind of went over. Now let's try to see if we can actually use the factoring techniques to be able to solve these equations. So here's our first one. So I'm going to just paste this down. And so for this equation, so what I'm going to do is I'm going to see, okay, so can I factor this out in some way? Well, if we try to factor out this equation, so what we'll have is, so here, so from this, now notice your a is just equal to 1, so I can factor this out if it's possible. So this is 36. Well, 2 numbers, okay, that give me 36, and I'm just looking at here at 5, it's negative. So 9 times 4 gives me 36, and so here, so I can make, okay, so the 9 will be positive, and then x, this will be minus 4, it will be negative, so that when you add them up, 9 plus negative 4 is plus 5, which gives you exactly what you have in that middle term, and then 9 times 4 is 36, and it's negative. Now these, when you are factoring these things out, and when you're trying to solve for this x, we call these solutions, we're trying to find the roots, okay, of the equation. Roots of the equation, or sometimes we'll call it the zeros of the equation. So that's what we're trying to find. Meaning, what value of x that you will substitute back in will make the equation 0. That's what you're trying to find. Now, you're going to have 2 values because the order of, or the degree of this kind of polynomial that you have, it's a quadratic. So you're going to have 2 of them. And one of those, they're going to come from one factor, and then the other one is going to come from the other factor. So for instance, this, okay, if you try to set this to 0, you'll know that x is equal to negative 9. And then this other one, if you set it equal to 0, then you know that x is going to be equal to 4. So those are your zeros or your roots, meaning x is equal to negative 9 or equal to 4, it will make this equation equal to 0. And you can check that. So for instance, let's just arbitrarily, for instance, let's take 4. So I'm going to have 4 squared plus 5 times 4 minus 36, so equals, so 16 plus 20 minus 36. And indeed, well, because 16 plus 20 is 36, minus 36 is 0. So you found the 0, you found the root of that particular equation. And you can do the same thing with negative 9, and you will see that that's what you would get. So that's one example, and this one we could factor out, and we can solve this equation for our unknown x value. Now here's another example. So this one, is a little bit harder, and the a is not equal to 1. So our first kind of original goal is, okay, so can we factor these things out in some way? So this quadratic right here, can I factor it out? So it's not as easy because I have 6 here, but I can still use the same strategy, right? So I'll take 6 times 20, so that's 120. It is positive there. All right, so I have that. So now I'm going to decompose this middle one. And so what two numbers when added together are going to give me negative 23, and when multiplied are going to give me 120. So I'm just thinking, so in here, so I guess I can decompose this, and it's going to be, so that's going to be what, negative 15x and then negative 8x. I guess if you do that, that's negative 23, and then 15 times 8 is indeed 120, and it's positive. So I could decompose that in this way. Now continuing, so now I can just factor this directly. So it's going to be, that's 1. All right, so factoring this out, how can I do that? I guess 3 I can take out, the x I can take out, that's from the first one, from that bracket. So that's going to leave me 2x minus 5, I guess, which means, all right, so what I should get from the second one, so from this one right here, I should also get 2x minus 5 in here. And in order to do that, I guess I can take out the 4. So that's going to be 4, right? So that negative, and indeed negative 4, and then that, okay, so gives you that positive 20. So that means this is in factored form, 3x minus 4, 2x minus 5 is equal to 0. So whenever you can factor these things out, then it makes finding the roots or the zeros of your equation much easier, because now what you have is you're going to take this factor, you're going to take this factor, and you're going to set it to 0. So for instance, so here, this is 3x minus 4 equal to 0. So solving, I'm going to bring this over on the other side. Divide by 3, and x is equal to 4 over 3. And that's one of the roots or zeros of the equation. And then here's the other one. So that's going to be 2x minus 5 is equal to 0. Bring that 5 over. That's 2x. Divide by 2, and you're going to get 5 over 2. And those are your zeros of the equation. All right. Now, it's basically a quadratic, right, that we have in terms of a polynomial that is given to us, that we're just trying to find what the answer for x is. And in these cases, we could actually find, so you have 2 answers, and you will always have 2 answers whenever it is a quadratic. All right. So that was example number 2, that we could solve that equation. Here's example number 3. So luckily, this one is going to be much simpler, because I can already see this is a difference of squares. So for this difference of squares, so if I'm going to, I'll copy this down. So let's copy it, and let's bring it down. So for this quadratic, there's no middle term, and it's a difference of squares. So this is 2x minus 3 and 2x plus 3, and there you have it. So that's factored form. And now again, I'm going to have 2 roots to this equation. So one of them is going to be 2x minus 3 is equal to 0. So we'll bring that 3 over on the other side. We'll divide by 2, and that's my first one. And then the next one, okay, it's just going to be negative, because I can see that from right there. And again, because it is a difference of squares, because you're going to bring this, and then you're going to divide by 2. So there we have it. So that's another example that you have, so you can solve this equation. And all of these equations thus far, we could factor them out. And again, this is just an introduction and kind of the first starting point of these types. And then I'll show you some other ways, okay, when factoring doesn't work. So here is another one. Let me copy this. Okay, and let's see what challenge this brings. So for this one, so you have x squared plus 8x plus 16. So can we factor this? Oh, this is actually a perfect square because you have 16. So the square root of 16 is 4. And then this, notice 4 plus 4 is 8. So this is actually just a perfect square. So that's kind of nice. So my roots in here, so whenever you have this, don't think that there's only one answer. Indeed, you have two factors, and they're like this. Now they repeat, which means that your answer here is x is equal to minus 4, and then x is equal to minus 4. So there's two of them right there. All right, so for this one. So technically it's the same thing. And then if you're thinking back in terms of the parabolas, it means that, you know, you have a vertex at that particular point because it's a perfect square. All right, so that's another example. Here's a final example that I have for you in terms of these equations and starting with them. What if they give us this? Okay, so I'm going to bring this to you. All right, and I'm going to say paste it. Now, with these vertex forms of quadratics, because, I mean, one thing you can certainly do is you can expand. You can expand this out and then put it in the form of ax squared plus bx plus c equals to 0. But it's kind of unnecessary because it's already in this vertex form. So what you can do is you can actually try to solve for your x directly. All right, and sometimes it works and sometimes it doesn't work. All right, now think back. So within here, think back what this means, because this is in vertex form if it was a relationship between y and x. So notice this 3 is pointing upwards. Your vertex is actually at 2, -9, right? So it would be at 2, -9, kind of at the bottom, and it points upwards. So it will have zeros. It's going to cross the zeros somewhere. So this one actually will work. But if, for instance, it was a -9, if it was +9, okay, I'll show you what would happen there, and then you would be stuck. All right. So how would I solve this? So the way I'm going to solve it is I'm going to just shift this over on the other side. So it's going to become 9. So this is 3x minus 2 squared. I'm going to divide by 3 on both sides. And this is x minus 2 squared. So this is going to be 3. Now notice, yes, indeed, I have a square there, but I can take the square root. So what happens is I can have x minus 2 is equal to the square root of 3. All right, now it's going to be the square root of plus minus. Okay, so that's what's going to be. And now move this over on the other side. So this is going to be x is equal to, it looks kind of weird, plus 2, because I'm going to move that over. So my answers, I have two answers because it's still a quadratic. And my answers are, so my first answer is plus square root of 3 plus 2. That's the first answer for x. And then the second answer, or the second root, would be negative this plus 2. All right, so those would have been your two answers. I'm going to leave it as the root. I mean, most people would typically just change this back into some decimal and then round it off. But because it's roots, in this case, it will be irrational numbers, so I'll just keep it in this way. But I did want to show you that, you know, you can also solve these equations like that. All right. Now, the problem is, so what I said here, if this exact same equation, and this is what you're going to start running into, because they're not all factorable, and you can't always easily solve these things. So for instance, if I would make this plus instead, so that means if you're thinking about a parabola, so it's looking up, and the vertex would have been actually 2, 9. So it's looking up, all right, so it's kind of looking like this, and, you know, so this is, okay, at 2, and this is at 9, all right, sorry, this is at 2, so it's kind of shifted upwards, because the 2 9s, so it would have been kind of like that. But now, if you're looking at this, well, wait a minute, this parabola would have never actually crossed through the 0. That means there isn't actually a solution to this that we can find. So if you were solving this, notice what would have happened. You would have brought the negative, so this over, and it would have been -9. Now, it would have been 3x minus 2 squared. You can divide by 3 on both sides. So now you have this. But now you have a problem because you have a -3. So if you try to take the square root of both sides, you can't take the square root because you're not going to get a real number out of this, right? So the square root, so if you're going to try to take, okay, the square root of a negative number, well, it doesn't work. So what that tells you is that this actually doesn't have a solution. There are no roots in here, okay? So you cannot find an x, which is just a real number that you can plug in here so that this whole equation is equal to 0. All right, and it kind of points back if you're thinking about parabolas and understanding quadratics, because that's what it means. It never actually crosses through here, never crosses the 0, ever. All right. Okay, so this is just the introduction. So the goal was, if you can factor things out, then you can find your roots or your kind of zeros of the equation. And now we're going to get into other videos where what happens if you can't do it. What are some of the tricks that you can use? Okay, and one of them will be perfect squares. All right, we'll see you in a future video. Bye, everybody. Cheers.